Right, so let's do this one. Number complements. It's an easy one, so I'm going in totally blind and just, using this as some practice of communicating what I'm thinking. I think I'm going to do a new system where for an easy one, I'm going to go in blind. But for a medium and a hard one, I'm going to be more inclined to look up the solution and spend the time trying to explain it because I'm starting to recognize that it's not necessarily about deriving your own solution, but sometimes it's about learning the solution, and going through a solution is enough of a challenge in itself. Yesterday's daily problem was a great example of that. Despite me looking up the answer, I feel like I learned more as a result, as opposed to me trying to figure out that complicated problem and then eventually giving up. So if you have a same, I would recommend that system if you are also doing LeetCode problems. But I'm happy to talk through it and provide a second voice. Let me know if there's any way I can be more helpful. I appreciate everyone who's watching these. All right. Number complement 476. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zeros in its binary representation. For example, the integer 5 is a 0, 1, 0 in binary, and its complement is 0, 1, 0 when the integer is 2. Given an integer num, return its complement. Okay, so let's see. So the first thing is we're probably going to want to make use of the binary representation in this. But how so? Is there? I feel like so it's an easy problem. I feel like there's an easy way to go about this. But right now, my first thought is to just, let's see. So you're returning an integer. So you could get the string and then just go through all the characters in the string and flip them. I feel like there's an easier way to do this, but this is my first thought, and I'll look at solutions afterwards. Okay, so binary string equals bin num. Okay, so that's going to give us the string. So if it's 5, then that's going to give us something like, it's going to be ob. Let's see, what's binary? It's a 2, or sorry, 1 1. No, 1 0 1. Yeah, because 4 plus 2 plus 1, then you skip the 2. So 4 4 1. Okay, so now we're going to go through all those. We're going to say just digits equals binary string 2 onwards. Okay? Now we want to flip those. So 4 digit in just digits, and we're going to make a return value. So we're going to say complement string equals, actually I'm going to comment this all out. Get binary representation. Initialize complement string. Cut off OB. Iterate through and concatenate flipped bits. So 4 digit in just digits, we're going to say complement string equals so let's see, if it's a 1, we're going to say complement string plus equals 0. Else complement string plus equals 1. So we're flipping them. Okay, now we have a string of the complement, but now we need to get it back to not just being an integer, but a, well, yeah, not just being a number, not a string, but rather a, oh, you know what? Maybe we could just skip a step. Could we just, like, skip a step? Why bother? Because I'm thinking about it. This is a good, okay, this is a good one. Why bother flipping the bits and then interpreting it back to an integer? Well, you know, a number, a binary number, and then into an integer, when I could just flip it right back into. I could just turn it into an integer right now. So I'm gonna delete this, and here's what I'm gonna do instead. I'm gonna go backwards through it. Yeah, okay, here we go. I'm going to go backwards through it and add up the integer. And the reason I'm going backwards through is because if we have 1011, you know, at least the way it works in my head is you add up 1 and then 2 and then skip the 4 and then you have 8. So that would be 11. And you can't go, like, you can't start with this one because you don't necessarily know how long it's going to be. So we're going to say, okay, sorry, I'm spacing out. Okay, here's what we'll do. So we're going to start this. We're going to say binary place equals 1. So we start at the ones place. Okay? Now we'll say complement equals 0. If the digit, now we need to go backwards through this. So we're going to say for I in range just digits. I mean, we could do reversed. No, I'll just do range and then subtract. For I in range just digits. If just digits. Actually, maybe this could be just bits. That's more accurate. Or it's a more fun name for it. If just bits I let's see, we're going to get bits length equals length of just bits. Sorry, this is getting a little convoluted. I hope you're following along if you're watching. Bits length equals length of just bits. I'm going to say for I in range bits length. And then we're going to say bits length minus I minus 1. Alright, so if that's, and yeah, we don't need to worry about the ones now, because if it's a 1, then we just don't add anything, because the complement, that place would be a 0. Okay, so this will make more sense once I get it written out, if it works. Okay, let's see if this works. Oh, oh, yep. Tiny mistake. Oh, hey, come on. Let me try now. 3, 2, 1. None is not a valid value for the expected return type integer. Where does that happen? Oh, because I never return anything. Oh, silly old me. Return complement. Cool. Let's see if it works, and if it works, how well. Oh, hey. Yeah. All right. That's cool. That's cool. So now with these shorter problems, I always feel like it's a little bit luck of a draw. I mean, like, because it actually can vary with those milliseconds. I have a feeling that I kind of got ahead of the pack because I think that a lot of people probably did what I was about to do, which is turn it into another the complement string, and then turn that back into an integer when you could just skip all those and just turn it right into an integer. The memory also, I'm really proud of that. That's an awesome solution. That feels great. Okay, so let's go through that one more time. So remember, we're making the complement of the binary representation of well, the complement is the binary representation. Yeah, we're making the complement of a number. So we have binary. So we're first thing we do is we're going to turn it into binary, so we can just go through the ones and zeros. We're going to lop off the 0 and b, because with Python, when you turn something to binary, it's going to represent it with OB and then whatever it is in binary. We're going to initialize a complement that we're going to add up over time. We're going to take the binary place. We're going to set that to be 1, and we're going to increase that by 2 over time to represent it. So if you have 1, 0, 1, 1, actually it'd be the complement, but you'd start with the 1, and that's just going to be 1. And then, what was it? Then we have the 2, so that's 2. Then we skip the 4, and then we go to no 4, and then we do the 8. So we're going through that, and so we're doing the opposite of that. If we get a 0, then we add the current binary place. If we get a 1, then the complement in that spot would be a 0. So you just so you ignore that, and then you return the final number. Yeah, so that's a great solution. I'm really happy with how that turned out. Thanks for watching, and hope this helps. Let me know if there's any way I can be better as a, I don't know if, yeah, for whatever you watch this for, I take, I've gotten a couple comments every now and again, and I take them very seriously. I mean, it's why I started doing the daily problems, is because someone said that it helps. So, yeah, thanks for watching. Have a great day.